So we have good old and Cirky gets everything right. Impulse. Well, there's two ways to calculate impulse, Dustin. There's final minus initial, and there's force times change in time. Which one am I going to use? Depends what they give me. Well, I notice an initial velocity, and there's a final velocity, 0. I'm going to use this one. This is going to be mv final minus mv initial, which is going to be 0 minus mass times velocity, negative 448 kilogram meters per second. I would give you 1 mark for that, half mark for that, half mark for the answer, but if you got the right answer, 2 out of 2. Why negative? This person lost momentum. A, what is the magnitude of the impulse? Impulse is change in momentum, and I think in this one as well, I'm going to go mv final minus mv initial. It's going to be 10. Final is 12 minus 10. Initial is 20. You get negative 80. Now, if you said negative 80, I'm fine with that. Technically, it just asked for the magnitude, so if you said that, I guess I'll give it to you. But the negative is saying that object needs to lose some momentum. B. What's the force? Well, another way to think about impulse is force times change in time. In other words, another way to think about force is the change in momentum divided by the time. Is negative 80 divided by 5 is negative 16 newtons, yes? Now again, because all I asked for was the magnitude, if you just said that, I'm fine with that. What the negative is telling you is the force is in the same direction as the change in momentum. Same as usual, 1 mark, half mark for both of those. Number 3, ooh, we have a collision. And it wants me to find a final speed or velocity. This is a job for conservation of momentum. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Because before the collision, what's moving? Mass, let's call this mass A, mass B, or both?
Or mass A, sorry.
Momentum of object A initial. You could also have called it mass 1. Yes?
Yeah.
When they collide, after the collision, what's moving? Mass A, mass B, or both? Stuck together or separate? Stuck together. Oh, that's nice. That's going to be then momentum. And then we always, from now on, pause. Are there angles in this question? Oh, so I don't need to go tip to tail and vectors. I can go straight to saying M A V A initial equals M A plus M B. Anybody notice that actually apparently this question was identical to the one in the homework, the example that we did? Completely down to the exact same numbers. I've changed the example in the homework for next year. Apparently I was cutting and pasting and forgot to change numbers. I never do that. Oops. Because what are we trying to find? Which is going to be MAVA initial divided by mass A plus mass B. 3.2 times, whoops, 3.2 times 1 point, wow, come on, pen. Well, the battery's dying on this thing, but I'm trying to get a little more life out of it. Out of 3.2 and 1.8. Is it 0.764? 6.8? That was totally going from memory. I didn't do that one in my head. Meters per second. Positive in the same direction that they were traveling. If you got that, you would get 4 out of 4. Otherwise, I would probably go half mark, half mark, half mark, half mark, 1 mark, 1 mark. Sorry? And then I would turn the page. Question 4 is identical to question 3, but instead, I want to know how much kinetic energy we lost. You know what? I'm still going to find what the speed was. I'm still going to start up by saying, oh, the sum of all the momentum beforehand equals the sum of all the momentum afterwards. Before the collision, what's moving? Mass 1, mass 2, or both? Both. I'll call this mass A. I'll call this mass B. Both stuck together or separate? Separate. East and east, although they mention directions because I don't see different directions, so I don't think I need to draw a compass rose. I don't think I need to go tip to tail. I think I can go momentum of A initial plus momentum of B initial. Right? Wham! They collide. After the collision, stuck together. This is going to be mass A, V, A initial plus mass B, V, B initial equals V final divide by, I did 2 steps into 1 if that's okay. I said, you know what, the mass of both is going to be MA plus MB, but I'm going to end up dividing anyway. Is that okay, Clay? Just always emphasize, remind myself, I better pay attention to rebounds and direction if there are any. I get the final speed after the collision is going to be 4.2 times 1.6 plus 1.8 times 0.6, all divided by 4.2 plus 1.8. That gives me bracket 4.2 plus 1.8. Do you get a final speed of 1. Oh, nice, 1.3? Which is not what this question wanted me to find. This question wanted me to find the loss in kinetic energy. Well, really, it's asking me to find the change in kinetic energy because I lost, which is going to be final minus initial. It's going to be a half 4.2 plus 1.8, the mass of both, because that's what's moving in the final, 1.3 squared. Take away, how many things are moving at the beginning? 2. So how many kinetic energies are there at the beginning? It's going to be take away a half times 4.2 times 1.6 squared, and also take away a half times 1.8, running out of room here, times 0.6 squared. .5 bracket 4.2 plus 1.8 times 1.3 squared. Take away bracket 0.5 times 4.2 times 1.6 squared and 0.5 times 1.8 times 0.6 squared. Do you get negative point? We lost 0.63 joules. Is that right? No? Yes? No? Okay, let me check. Maybe I made a typo. A half 1.3 squared. Take away this whole mess, which is going to be a half 1.6 squared plus a half 1.8 point. Is that not right?
I got that.
Oh, yeah?
Yeah.
Okay. And the negative tells us we had less energy after we lost kinetic energy. If you didn't say your answer was negative, I won't freak out because I just said how much was lost, and you could easily say, oh, 0.63 was lost. Is that okay? Joules. In terms of part marks, I would probably give a half mark for that, half mark for that, half mark for that, and a half mark for getting V final. So you get 2 out of 4 for finding V final. Then I would give you a half mark for that, 1 whole mark for that, and a half mark for the answer, for realizing, oh, I need to find the change in kinetic energy. Is that okay? Number 5. Well, I know there's a collision, but number 5 is asking me to find the impulse. You know what? I have a final velocity and initial velocity. I'm going to find the impulse by going mv final minus mv initial. M 3.5. Oh, I have east, I have west. I'm going to let one way be positive, one way be negative. I'll let, because I suspect most of you let east be positive, and did most of you let west be negative? So I'll do it that way. So my final velocity of car A is west, so it's going to be negative 0.6 minus 3 minus 3.5. My initial velocity is going to be positive 1. And I'm going to get you could have let the initial be negative, by the way. If you told me the answer was positive 5.6, I'll give you full marks. Here's what I'm going to say. I got negative 5.6 kilogram meters per second, or as a direction, what does this negative mean? What? Why? Oh, that's what I defined it. So, or you could say 5.6 kilogram meters per second west. Is that okay? Oh, 1 mark, half mark, half. Yeah. So you could either say that, or you could say 5.6 west. What I wouldn't say is negative 5.6 west, because negative west is east, in my mind. No. I let west be negative, and I got a negative answer. Right? The change in momentum that the cart A experienced was to the west. Was. Okay? Oh, what impulse did cart B undergo? Pardon me? Because momentum is conserved. No. If car A gained lost 5.6 kilogram meters per second in the west direction, that's because car B gained that much. Now we can crunch the numbers. Remember, I said find the impulse. I didn't say find the final velocity. I didn't say find, then you'll have to go. So if you said, hey, there's a collision and you found V final of the car, you could have. But I'm telling you, for what it's worth, momentum is conserved, which means if we had some momentum go in the west direction, 5.6, or if you want to think about it, negative 5.6, there must have been positive 5.6 in the other direction. Otherwise, how the heck could momentum have been conserved? Momentum's got to come from somewhere. Find the final velocity. So now I can actually go like this. Impulse equals mv final minus mv initial. Whoops. I can say mv final equals the impulse plus mv initial. All I did, Spence, was plus that to that side. Oh, and you know what? I guess if I divide by the mass, I'll have v final by itself. 5.6, that's my change in momentum, plus mass of car B, 2.8. Initial velocity of car B, west. So I'm going to call that negative 0.8 all over mass of car B, 2.8. And I end up with a final momentum, sorry, a final velocity of positive 1.2. The fact that I got a positive answer tells me what? East. Again, Clay, what are you saying? You're saying you got 1.2 for this one here?
No, I got those two wrong, but then I got C right. And I didn't do it like here.
You could also have done it by doing it as a collision. You could have said before the collision what's moving. And so, which would have worked because you didn't use your answer from part B, which you got wrong, to find part C. You'll notice mine was quicker. But, by the way, you're right. I used an answer from part B to find part C, which is bad test writing. I could have solved part C using only the data that they gave me because, wham, they collide. And that would have worked just fine too. Oh, but since there's a change in direction, I would have had to have been consistent. I would have let east be positive, west be negative, which would have worked. Oh, how much kinetic energy was lost during the collision? That's going to be KE final minus KE initial. Before the collision, what was moving? Car A, a half times 3.5 times 1 squared, plus car B, a half times 2.8 times 0.8 squared. Mr. Dewick, shouldn't you let the 0.8 be negative because it's to the west? Energy is a scalar, I don't care. Also notice, because if I put a negative in the 0.8, when I square it, what would happen to that negative anyhow? It would vanish. So here is, oh, you know what? That's initial kinetic energy, Mr. Dewick. You should have done final first. So let's be clever. There's the initial, haha. Let's now do the final. What was the final kinetic energy? Well, that's going to be car A, a half times 3.5. How fast was car A going afterwards? 0.6 squared plus a half times 2.8 times 1.2. That's my answer from part C squared. It's going to be that. Bracket 0.5 times 3.5 times 0.6 squared plus 0.5 times 2.8 times 1.2 squared. Close bracket. Take away bracket. A half m, I'll come back to it in a second, 1 squared plus a half m 0.8 squared, close bracket. Let's see, a half mv squared plus a half times 2.81. 2.81. Oh, another, you know what? Another times didn't show up there. Okay. A half times 2.8 times 1.2 squared minus a half times, does that look okay? Do you get, oh, 0? Where's my typo here, Mr. Dewick? Maybe no energy. Maybe this is a perfectly... Is the answer 0? Yeah? Oh. This was a perfectly elastic collision. No energy was lost. If I hadn't just made fake numbers to get an interesting question, yes. But here was an example of one where no kinetic energy was lost. Okay. I sense there were some discrepancies on the quiz. Remember, you can always redo the quiz and do your corrections. But hopefully, looking at this now, I heard somebody say, oh, I made this way harder than it needed to be. In a nice straight line, if you don't panic, it ain't too bad. There's lots that we can do. Any questions? Any lawyering with me? Otherwise, if you would be so kind as... I'm going to pause the video. Lesson 3, more 2D momentum. More stuff with angles. And you know what, Mitch? We're probably not going to have too many right angles. Like this. I like example 1. You're going to have one very similar to example 1. In fact, I took this question from the last lesson. I've just changed the numbers. On your test, you can expect you'll either have something coming in a straight line and then banking off an object for 2 angles, or you might have 2 objects coming in at angles, sticking together and moving off in a straight line. In other words, flip this diagram around, but you're going to have 2 slanties and 1 straight. Okay? What does this question want me to find? A velocity, magnitude, and direction. Is there a collision? Yes, there is. Well, you know what? That's a job for conservation of momentum. Did I give you guys a whole page for this? Okay, then I don't need to write too small. I probably could have put that. You know what? I will. You guys can leave it there, but I'll do that. And I'll do my big vector triangle over here. Before the collision, looking at Mr. Duick's skillfully drawn picture, by the way, what's moving before the collision? Mass A, mass B, or both? Okay, so it's going to be mass A initial, right? How do you know that mass B isn't moving? It says VI is 0. If I hadn't said that, we'd be out of luck. But because I said that, fancy word at rest, or the other word they'll use is stationary. Is that all right? Good. When they collide, after the collision, what's moving? Mass A, mass B, both, or neither? Did I get Kohei again? Yeah? Stuck together or separate? Separate? Okay. By the way, if they were stuck together, this would be nice because you would have to have everything horizontally because since you have no other vectors involved, this would be much nicer. Now, though, it's going to be momentum of A final, momentum of B final. Kohei, are there angles in this question? Are there? Oh, you know what? I'm going to draw up here a little north, east, south, west so that I'm consistent. Yes? And now I'm going to draw a little picture. I'm going to dulp. Kohei, look at the initial momentum of object A. It's due east. So I'm going to draw that. This arrow is this momentum. How big is this arrow? This mass times this velocity. Can someone go 12.1 times 8.5 and don't round off at all? Sorry? 102.85? Is that right? When they collide. After the collision, it looks, Kohei, as though mass A moves that way at an angle of 38 degrees from the picture. How big is this going to be? Mass times velocity. So it's going to be 12.1 times 1.3, which is what? And don't round off. 12.1 times 1.3. 15.73? Plus. Now, I don't know exactly what object B looks like, but based on the picture, I can make a guess that it looks something like that. And this is going to be mystery momentum of object B final. I know its mass, but not its velocity. And now, Josh, if I wanted to, because this is what I'm trying to find, I could, because I think you asked this last class, I could minus this to this side, and then I could say it's going to be AI initial takeaway momentum A final. How do I subtract two vectors? I don't. I add the opposite, and that's perfectly valid. But I know one more thing. I know when I add these two together, the answer is supposed to be exactly horizontal. If that wasn't the case, I would totally use the subtraction method. But because I know what the answer is supposed to look like, I know that I can draw the vector triangle something like this. Here's momentum A, 15.73. And I know that momentum B, I'm going to stop right up, a little further. I'm going to stop right about there because the resultant is supposed to be exactly horizontal, 102.85. Now, just a small warning. Kyle, how far is it from here to here? How far is it from here to here? My scale is crap because this looks like it's about 60. If I kind of, so let's, the numbers that we get, if they don't look like they fit in our triangle, I won't freak out because I think my diagram is terrible. Oh, but I do have one more thing. Where does this 38 degrees go? Top left? Yeah. That works. Knock, knock. I'll ask the questions! No, just kidding. Knock, knock. Who's there? Cosine law, right? That was the KGB version of that joke, right? Knock, knock. Who's there? I'll ask the questions. That's how the KGB tell it? No? Okay. That was a little obscure. I don't know where that came from. Boy. Cosine law. Yes? So it's going to be, Dustin, also, last block, you guys needed a bit of a wake me up, so I'm yelling. It's going to be momentum B final squared, and it's going to end up being 102.85 squared plus 15.73 squared minus 2, 102.85, 15.73 cos 38. And Raj, although I wrote brackets, I'm probably going to use the times sign because it's so much easier to read. And less typing. Check for typos, Mr. Dewick. Square root, don't forget to square root. Do you get the final momentum of object B is, oh, you know what? I'm not going to round off because I know I'm going to use this to find other stuff. So I'm going to go 90.97153. What did I say? 97153. That should guarantee me at least 3 figs of accuracy. In fact, it'll give me more than that. Oh, if only we were done. It's not even what the question asked me to find. I've just found the final momentum of object B. Because what did this question ask me to find? If I know a momentum, how the heck can I find a velocity? Momentum is what times what? Oh, so how can I change this into a velocity, boys and girls? Boys and girl? Divide by the mass? So 90.97153 divided by, what was the mass of, oh, make sure you use the right mass. Which mass? And this is why you'll notice, Clay, I'm so careful with my labeling now, because there's plenty of room to pick the wrong thing. Mass B. Mass B, 4.2. And I get 21.7 meters per second. Now, if this question had only said, find the speed, we're done, because that is a speed. Did it say find the speed? It said find the velocity, magnitude, and direction? Okay. At. Why can't I use that angle? Why wouldn't that one help? Well, all lines are straight, Captain Obvious, but I know what you mean. It's not a horizontal or vertical line. It's a slanty next to a slanty. It's a nothing of nothing.
Could you theoretically say it's 6.11 degrees at 38 degrees north, east of south, west, or something like that?
What you could do is use the... You could drop a 38 right there, and then if you found this angle, you could add 38 to it, and you could get there, but it's extra work. Theoretically, what you suggested isn't mathematically wrong, it's procedurally wrong. We don't give directions by saying, oh, you're 6 degrees south of 38 degrees north of west. Huh? We would just say, let's do it in one measurement. I wouldn't accept it on a test, in case you were wondering. Oh, here's what we said. I can find that angle. Where does that angle appear in my triangle? I see either Spencer thinks he's Zorro, or he's trying to somehow show me some... you're saying this angle here as well? I agree. By the way, though, this angle here, what of what? North of south, east of west, what of what? Oh, you just caught that? I always say north of south or east of west because those are impossible, right? But
I've never noticed that.
Otherwise, I might accidentally give you the answer without realizing it. But I know if I say north of south, east of west, what of what, it'll never be north of south or east of west. I can tell you that. Pardon me? East of west? I guess that means turning around, but then I wouldn't be solving it with vectors, though, right? By the way, what is this? What of what?
North and south.
How big? Sine law. I think I can say the sine of theta over what? What goes with theta? The 102.85 or the 15.73? 15.73, what's across from it, equals the sine of 38 over what's across from it, which, Mitch, I didn't know at the beginning of this question, which is why I couldn't use the sine law to start out. Because sine law is easier. It's cross-multiplying. But now I know the momentum was 90.97153. Clay, what are you trying to tell me?
One fraction equals one fraction.
This is 1 fraction equals 1 fraction, so you're saying that 15.73 would just move to the front of the sign on the other side there? So you're saying on my calculator, I would type 15.73 times the sine of 38 divided by 90.97153? 256. Since I have it sitting there, I could copy that whole thing. What the? Oh! Inverse or arc sine, right? And I get an angle. I think it's going to be a fairly small angle because my triangle, I think, is yucky. Yeah. 6.11 degrees. Clay, we could fill an ocean with how did you not ever notice. So let's just not go there. Let's just keep going here, okay? Oh, these are long enough, you may have noticed almost always. I'll do my little, yeah. This is almost as tough as it gets all year. I'm proud. Yay! Number 3. Number 3. I'm just going to talk about, okay? What does A want me to find? And? What's a fancy word for speed and direction? Looking for a word that begins with letter V. Okay, is there a collision? Yeah. Are there angles? I see north and I see 10 degrees west of north. Yes. So it would be very similar to what we just did. Could we do it? Yes, Dustin, it would be cosine log, sine log. We could do it. What does B want me to draw? What would the initial and the final help me find if I went, for example, final minus initial? Change in momentum. How would I subtract 2 vectors? I wouldn't. I would add the opposite. But now that I had that, I could actually, part C, find the magnitude of the force, because impulse is also force times change in time, and the direction would be very, very similar to the impulse. Although, in this case, I got an impulse of, well, yeah, 21 point, anyways, we could handle it. It's a long question that would take us like 25 minutes. So as cool as it is, I'm going to pass, and I'm just going to say, hey, your homework right now, last day. Number 1, totally fair game. 2, totally fair game. 2 is an interesting vector diagram because it bounces backwards and to the left, but you can still get it by adding stuff tip to tail. It's tricky, but it can be done. In case you're wondering, your vector diagram would look... Ah, my pen just stopped working. I need to replace the battery on it. I will in a second. I think it's going to be this guy plus this guy gives you, like, I think your triangle is going to look something like that. That's that vector plus that vector gives you that vector. I'm going to erase all that because you should really do this properly. And I think I left you room to do this. Did I leave you room in the sheet to do this time?
Nope.
Oh, I didn't? Yeah, there's room there, isn't there? Some. If you write small, it's up to you. So number 2 is fair game. 3 is good. 4 is good. Yeah, 5 is good. 6 is good. 7, yeah, these are all good. I want to give you lots of time to work on this, so I'm hitting pause.